So to solve this question, we are going to take few of the points on the plane and mark it at number 1, 2 and number 3. So as we have drawn 3 points, now take any point like the black one. From that point to merge we will need 2 steps. To merge point number 1, we will take 1 step as it is lying on x is equal to constant line. So the steps taken would be x comma y plus k, the first step, and x minus k comma y. K can vary. So the total steps needed would be 2. From reaching to the point, this point, to point number 2, 2 steps would be needed. Similarly, for reaching from the black point which I had marked to point number 3, we will need 2 steps. Now let's draw some lines. One line parallel to x-axis, other line parallel to y-axis, and one line at 45 degree and the other line at minus 45 degree. Why are we drawing these points? These lines? Because as per the questions, to minimize, we should move in these lines. We should move our given points only in these directions. In that case, we will need only one step. Okay. So if we are making any kind of movement in these lines, then we will need only one step. So let's take the merge point of lines passing through 2 and 3, the intersection. Let it be point number A, point marked as A. Okay. So PT. Yeah. So from moving 2 to that point, we will need one step, and moving 3 also, we will need one step. So overall movement would require 1 plus 1, and for point number 1, we will need 2 steps. Now take another point which is not on any of this line, not either on the intersection or even not on the lines. So for each point to merge to that, each given point that is marked as 1, 2 and 3 in this case, to merge it we will need 2 steps. Hope you get it what I was trying to explain, like why we are only considering the points. First of all, why we are considering only points that are lying on these lines, because the movement will take only 1 point, cost only 1 point, and if neither the point lies on any of these lines, then to merge that point, one extra step would required. Okay. So now taking all the 3 points, let me draw the lines that I'm talking about and show the intersections. Possibly this will help. The points which are marked are 1, 2 and 3. Okay. So the blue lines are the lines passing from line number 1, and the red lines are line passing through line number 3. And also in this case you can see this line that is passing through 3 and 2 both is actually at 45 degree to both the points. So this is also one of the point number 2. Okay. So to move, take the merge point. This is the point number marked, let's name it as point A, and to move any of the 3 points, now to move we will need one step to move from all the given 3 points. Like from movement from 1 to point A, we will need 1 steps. Let me show you. So 1, say, to reach there we will need one step. 3 to that point we will need one step, and point number 2 to point A we will need one step. So all the total of this will be 3. Now any of the point that is not lying on these lines will cost us much more. Say this will take 2 steps to reach 3, 2 steps to reach number 2, and 2 steps to reach point number 1, 1, 1, and 1, 1. Okay, so total is 6. So if a point is not lying on these lines, then total drastically increases for each point by 1. So we can see for non-intersecting points, we definitely required for each point movement that is not lying on those lines, one step more is needed. So to reduce, we try to lie the points, the merge point, possibly on those lines, and we have seen for the intersection point, like the more number of the points are merging there, the lesser number of steps we will need. So that's why we are considering all the possible intersection points and then solving it. Now we can see, to minimize our required number of steps for merging all the given points to our point, we consider intersection point pairwise, like every intersection point for those lines passing from each and every given point on the plane, like 1, 2, 3 are given. So we will draw all the possible lines and take each and every intersection of all these lines. The intersection points thus calculated, I mean all those intersection point which we gather by this method must definitely contain that point where the maximum number of these lines are merging. Like say, possibly there is a point in the plane where, like, we have 100 points, so 50 of those are merging there, like 50 of those are having intersection there. So then in that case, that point will be considered 50 times in our calculation, and for that point our cost will be definitely minimum, because it will give 50 points lesser, like 50 of those points will need only one steps and the rest will require 2 steps. So the maximum number of points are merging, the minimum the cost will be. And how we will do that? We will take pairwise possible and then calculate for it. Like to this point, 1, 2 and 3, all those are intersecting. So for all those, we will need only one step and the total cost will be 3 steps. Similarly, for the 50 I have explained, this is a similar case that I have just now drawn. So now we have understood why we are taking the intersection point and not all the possible points, because all those possible points will be very high and the time constraint will not be satisfied. So what we will do, we will take, for the coding part, we will take all the points and all the lines passing through these points. The lines passing through these points will have some definite equations, because these are only for let's just say any of the point, there are only 4 lines that are passing. Those 4 are x is equal to constant, y is equal to constant, x plus y is equal to constant, and x minus y is equal to constant. So now we will take pairwise. So let's say there are 3 points a, b and c. So we will take each pair a, b, b, c and ac, and for each pair we will take all the intersections of all these possible 4 lines passing from each of the given points. So by this method we will extract our intersection points forming by these 2 points, and then by the other 2 points, and then other 2 points, and so on. So we will consider pairwise all the possible points, and for all those possible points we will consider all the intersection points. So now say our points are x is equal to c, y is equal to x plus y is equal to c, and x minus y is equal to c. So pairwise we will form 6 equations, that is x is equal to constant passing from one point and y is equal to constant passing from another point. Similarly, for all those equations, there in total will be 6 pairs, and for each pair we will calculate the intersection point. So by this we will get all the intersection point. And one more thing, don't forget to consider the already existing points also. Like we should also consider point number 1, 2 and 3 that we have drawn as our cases to be as merge points, because for those points we are reducing one of the movement by 2 steps. So for smaller number that might possibly give us a result. So it would be good to consider those points also. So x is equal to constant and y is equal to constant. If we iterate it to all the points all the time, then we will definitely take these points in our account. So these are the intersection points. We can see all those intersection points will be automatically considered in our equation, and for those points we will calculate the steps. Like if the line is on the line, I mean if there is any movement possible in those possible direction to that point, then 1 step, then otherwise 2. Hope you guys understood the concept and the approach which we have taken. So happy coding. And thank you for watching. Please don't forget to subscribe, like and share for more such contents. Thank you.